In this video, we will talk about counting problems that involve using the complement. So let's get into an example, which says that a website requires passwords whose characters can be letters, which are A, B, C up until Z, or digits 0, 1, 2 up until 9. The passwords are not case sensitive, which means that an uppercase letter and a lowercase letter are treated the same. So we actually looked at part A of this example in the last video. Now we're going to look at part B, which says how many passwords with 10 characters have at least one Z in them. Okay, so let's talk about how we can do this. So the first thing that I want to notice is that if we try to do this directly, we would have cases. Because, if there's at least one Z, well, that means there could be one Z. And there don't have to be. There could be two. There could be two Zs. There could be three Zs and so on. And, even within each of these possibilities, if there was one Z, well, the Z could be in the first spot. And then I could have something else in the second spot and something else in the third and ... up until something else in the last. Or maybe the one Z is in the second spot. So maybe it's like something and then a Z and then something ... up until the last thing. And I could keep going like this up until like maybe the Z is in the last spot. Maybe the Z was in the last spot and then everything before that is, something different. And that's just if I had one Z. I could also have the situation where there's two Zs. And if there's two Zs, maybe the Zs are in the first two spots. And then everything after that is different. Or maybe there's a Z in the first spot and then something else. And then a Z is in the third spot. And then it's other stuff after that. And there's many, many others. Many other ways I can place these two Zs. And well, then there's the possibility that there's three Zs and four Zs and so on. So counting directly like this with cases seems super tedious. So it's very tedious. Very tedious to do this with cases. Okay, so I'm going to put a sad face. So here's an idea I can use to get around that tediousness, which is I can instead try to count the opposite of what we want and subtract that from the total number of passwords. So what I mean by opposite is the complement. And we've seen this term before back in chapter 2 when we talked about sets. So remember, the idea with complement was if I have my universal set, and the universal set here is going to represent all the passwords, or in this case, the total number. Let me just say all the passwords. So it'll be all the passwords, all the total possible passwords, all the passwords. And the stuff that I care about, I'll represent as a circle, are the passwords that have at least one Z. So the way I'm going to count this circle that I'm trying to get is, well, let's count the total number of all the passwords. Let's subtract away the complement. The complement is the stuff in pink that I'm shading in. And if I subtract that pink stuff away, it'll leave me with the circle that I want. So that is going to be my idea here. So, okay, if I'm trying to count the number of passwords with at least one Z, remember this absolute value notation just means the number of, the size of the set. Well, what I'm going to do is I'm going to count the number of total passwords, and subtract the complement. So what is the complement of at least one Z, the password having at least one Z? Well, it's having no Zs. So I'm counting the number of passwords with no Z in them, or with 0 Zs in them. Okay, so for the total number of, didn't mean to erase. For the total number of passwords, well, I can count that. Total number of passwords for each spot, for each character in the password, there's 36 choices. because it could be any one of the 26 letters or 10 digits. So there's 36 choices for the first spot, and then 36 choices for the second character, up until 36 choices for the last character. And my password has 10 characters total, so we're multiplying 36 times itself 10 times, and that gives us 36 to the 10. 36 to the 10. Okay, and then I got to subtract away the number of passwords that have no Z in them. And if there's no Z allowed, that just means there's 35 choices for each character, because it could be anything except for the Z. So that means for this, I'm going to be doing 35 times 35 times dot 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 times 35 10 times. We're going to be doing this 10 times because there's 10 characters that we are filling out. So this gives me 35 to the 10 power. And then I just got to subtract those. The number of passwords that have at least one Z is equal to 36 to the 10. That's the total number of passwords. Minus the number of passwords that have no Z, which is 35 to the 10. And we got it. And notice how much quicker that was than trying to do this directly with cases. So that is the real power of counting with complements. Sometimes trying to count whatever it is that the problem wants us to get is quite hard to do directly, but counting the complement is much easier. So that is a strong tip-off whenever we see something that seems hard to count directly, to try counting the opposite and use this complement idea.